But we didn't do this.
Hey guys, welcome back to our channel. Today we're doing some quay.
See if I can record this.
Oh.
Need a heavier object, that's what I need. Alright, someone to stand here and just wanna.
I can do it. If I can
Okay.
sit in the spin chair.
So, I'm going to prove that sine of negative u is equal to negative sine of u, okay? And I'm going to use the theorems, the axioms that I have on the sheet that I will provide to you. One of them is this, right? Sine of x minus y. So, x is 0, y is u, right, in that theorem? So this means this is equal to sine of 0 cosine of u minus, also look at this, I did this one. Minus cosine of 0 sine of u, right? So what is that? It looks like I've got sine of 0, which is 0, minus cosine of 0 is 1 sine of u. Negative sine of u. There you go, right? So that's a pretty quick, easy proof, right? And so there I'm just using, again, some of the basic fundamental other trigs that I can, yeah. Now this is something we've already said we know, right? You can even think of sine of a negative 45 degrees. The sine of that is negative root 2 over 2. What's the sine? Which is also known as the negative sine of pi over 4, right? So, just an example. Okay. And so let's see. Also using some of those trig formulas we have, let's say so therefore sine of theta is what? The square root of 1 minus cosine squared theta, right? I mean, these are just kind of manipulations of axioms that we know. We also know that 1 plus tangent of x is squared is equal to secant squared x, and that would say that secant, or we can say that tangent of x is the radical of 1 minus, or sorry, secant squared x minus 1. So just some basic algebraic manipulations of some of the trig formulas we know. Right? So find the 6 trig values when secant is negative 3 over 2. So you can actually use our trig identities to find what this is, right? So secant, yeah, right here, right? So if I know secant of x is -3/2, then I can say what? Tangent of x equals the square root of -3/2 squared minus 1, which is the square root of, this is going to be 9/4 minus 9/9, square root of, yeah, oops, sorry, 4/4, which is 5/4, right, radical 5/2, and that would be what? That's tangent, right? So secant is -3, secant is 1/cosine. Cosine is -2/3. Tangent is √5/2. And that's going to be sine over cosine, right? You can go on and, so you guys see what I'm doing there? Right? So I'm using the fundamental trig ID. So if I tell you what secant of x is, you can use these fundamental trig identities to find the other values, the exact values, right? I mean, you could say, here's x. Secant is 1/cosine, so secant would be 2/3. So it would actually be down here. 2, right? But that's rather generic, actually, right? So it could be,
Wait, that's not a possible try.
maybe 6/4. It could be all kinds of things.
Is that triangle even possible?
Hold on. Cosine, sorry. Should be over here. Just in the -3 and 2.
Because the hypotenuse can't be. Isn't it?
Right.
It's really a 3, 2, so.
Yeah, so this is not a real triangle, right? Yeah. So,
Yeah. Well, if it's secant though, then it's actually flipped.
1/cosine.
It should be 2, 3, because secant's reversed.
Yeah, like that.
So I mean, it is actually
Oops.
a triangle. It's just.
Oh, sorry, yeah. There we go, that's better. So it should be
The hypotenuse is 3 and then.
3 and -2. There we go, sorry. So that's what it should look like. And but again, that isn't more of a generic. So I don't know if secant was reduced or not. This tangent is √5/2. Over 2, so this is a -√5. So actually, yeah, it's over there. It is in quadrant 3, right? But here, I can actually just use the trig identities to find out what x is. Not what x is, but what the other trig functions are. Using this one, and the other one that I gave, right? So I can use these various trig identities. Given what secant is, I can use them to find out what the 6 trig identities are. Because again, tangent of x is just secant squared x minus 1. And just take the square root of that, right? Okay, so that gave me tangent. What was the other one I had? 1 plus cotangent squared x is cosecant squared x. So and I have cotangent, right? So cotangent is just the inverse of tangent. So that would be 1 plus, here's tangent. If I square it, invert it and square it, I'm going to get 4 over 5. And that's going to be cosecant squared x, right? So then to find cosecant, I just take the square root of that. And is 9 over 5. So 3 over root 5, which would be 3 radical 5 over 5. And then that would be cosecant, and so the sine is actually inverse of that, sorry. Root 5 over 3, right? And again, I'm taking the 3 fundamental trig identities that I have, and I am taking, given that I know secant, I'm plugging secant into one of them, this one, where secant is part of the trig identity, right? I plug it in there, an actual number in there, and then I have the tangent as a variable, and I just solve for tangent of x, right? And then once I know tangent of x, I can kind of use the other ones, sine and cosine and all the other things, right? Yeah?
Could you give us a worksheet with a few of these problems that we can solve like on our own?
Yeah. So. Here's actually got a simplification for you. So before I erase that, simplify this. Yeah, can you simplify that to like get it down to something simple?
Yes, give me a second. Is this a trick? Is it possible?
Yes.
Okay. And the sine isn't squared, just the cosine?
Correct. So think of this as like a b squared minus a. Okay? What would I do with ab squared minus a? Sort of. Factor? Okay, so do that with that one. So what if you do that, what do you get?
Can you do that if they're on different sides of the equation?
Well, no equation here. I'm just simplifying the statement. So that's just minus, no equals.
Oh.
Okay. So I could factor out the sine x.
So it's sine theta parentheses cosine squared minus 1.
Yeah. And what is cosine squared minus 1?
Oh. What is that? Sine.
So if I did minus 1 is negative. So yeah, it's negative sine squared, right?
Yeah.
If I go minus 1 minus theta minus 1 minus.
But you said it equal to something in that.
Yeah, so I get cosine squared theta minus 1 is equal to a negative sine squared theta, right?
How'd you get the squared in there when there's no squared in the first place?
Where?
That's just the identity that he's using.
Here, the identity is cosine squared plus sine squared is 1. And here I have a cosine squared theta.
Oh, so you just filled it in for the 1 there?
Yeah, so I took this cosine squared x, which is actually, I turned it into this, right? I factored this out, and I got cosine squared minus the 1 that I'm left over with, right?
Okay, so you end up with sine cubed.
Yeah, so I get sine x, and then cosine squared x minus 1 is actually negative sine squared x. And so I get negative sine cubed x. Yeah, right? Let's see. So for the one that I did just before this, try number 11 in the book, which says tangent theta is 2, sine of theta is less than 0. Okay? And do cosecant theta is negative 5, cosine theta less than 0. Right? So if tangent of theta is 2, find the other trig functions. And you can use this one and basically you can use the formulas that you have the sheet of right now. And I'll get you this tomorrow. I'll go make copies right now on my way back. This says, here, tangent squared is 2. Well, I know that tangent of theta is equal to square root of secant squared theta. Or, actually, let me reverse that. Sorry. I know secant theta is equal to the square root of 1 plus tangent squared theta, right? And so then I could use this. So secant squared theta is 1 plus tangent squared theta, right? I just take the square root of both sides. And now I've got secant theta is 1 plus tangent squared theta. And this will give me secant theta, which of course will also give me cosine, right? And so let me erase this. Okay, so here we go. Tangent is 2, so secant theta is going to be equal to the square root of 1 plus 2 squared, right? There you go, radical 5. So secant is radical 5. So I've got tangent is 2, so cotangent is 1/2, right? I've got secant, which is radical 5. So then cosine is 1 over radical 5, which is radical 5 over 5, right? Square root of 5 over 5. So what is sine? I could go 1. I could go sine of theta is equal to the square root of 1 minus cosine squared theta. I could do that, right? Or yeah, I could use tangent, and sine over cosine is tangent. Okay. But this is using that 1 sine squared plus cosine squared is 1. Okay. And so cosine is radical 5 over 5. So that's going to be the square root of 1 minus root 5 over 5 squared is 5 over 25. 1 over 5, right? Equals the square root of 4 over 5. So sine is going to be 2 over radical 5, which is 2 radical 5 over 5. And cosecant is going to be radical 5 over 2. Right? So Do this, yeah, practice this one. And we can do it tomorrow in class. Okay. All right, guys. So hopefully I'll have that up